Okay, the idea of this video is just to give some top tips for how to work with parametric equations. If you're going to plot a graph, you're going to have x equals some function of t and y equals some function of t, for example. So my suggestion is pick some values of t. Obviously, if you're at this level, you might be not just picking a few random ones and doing it more intelligently, but that's just examples. Wham some pairs in, start plotting a graph, and you should be able to sort it out. Okay, what's next? Ah, yes. Suppose you have to find the Cartesian form and you know the parametric form. I would say there's three main ways of doing it. The first thing is just to substitute one into the other, the way we often solve simultaneous equations. But quite a nice one, which I sometimes forget, so I like to have it on in my systematic approach. Rearrange both equations so they're just t equals, or whatever the other parameter is, but often it's t, and then just make them equal to each other. And the other one, which I often also forget as well, you can use an identity. We know that cos, for example, cos squared t plus sine squared t equals 1. It's universally true because of our definition of cos and sine, yeah, because we designed it from the ground up and that. Anyway, it's not magic, it's because of how cos and sine were created. But the point is, that means if you can write down cos t equals blah 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 and sine t equals blah blah blah, blah from the two equations, then you can substitute them in. Let's do the next thing. How do you differentiate? This is how you differentiate. Ta-da! And remember to do 1 over, which I don't even bother learning as a rule. It just seems so obviously true to me. And obviously this is an application of chain rule. How would you integrate? You integrate like this. There's lots of complicated reasons why it's true, but you could just remember that these two cancel and you end up with y dx. But they don't really cancel, they can't, because the parameters of the integration are t. Finally, I often find I have to find out where a Cartesian curve crosses a parametric curve. There's a really easy way of doing this. You substitute the two parametric equations into the Cartesian equation. There you go. If you're one of my students, that was everything we usually cover about parametric curves really quickly for your revision and to look at between tutorials. And if you weren't one of my students, hopefully that was helpful.